Okay, when we want to look at molecular formulas, we're going to take the steps from the empirical formula problems and add one additional step to find the molecular formula. In ionic compounds, empirical formulas indicate the simplest whole number ratio of the elements in that compound. Any empirical formula will tell us that, but in an ionic compound, that's going to be the only formula we will ever see. Covalently bonded compounds, or molecular compounds, are compounds that are held together based on sharing of electrons in that atom, and because of that, the molecular compounds are not held together by charge and therefore combine together in more complex ratios often. So a lot of times the empirical formula will only tell us a little bit of information. We actually have a more complex formula known as the molecular formula that we'll want to look at. The molecular formula will always be the empirical formula times some multiple. So the empirical formula is the simplest ratio. The molecular formula will be a more complex ratio with everything multiplied by the same number. To find that multiple, we do the molecular formula's mass divided by the empirical formula's mass. And the division of those will give us a number, and a whole number that we can multiply the empirical formula by to get the molecular formula. It's easiest to show this by looking at two examples. I would recommend that you try both of these examples first. Try with the first example, pause the video. Once you have an answer, press play again and see if you've done it correctly. Okay, for this first case, we have carbon, which is 48.04%, hydrogen, which is 8.08%, nitrogen, which is 28.02%, and oxygen, which is 16%. We can make all of these grams because we can make it out of a 100-gram sample. We're also given that there's a 200 gram per mole molar mass, which we will need when we find the molecular formula. So the first step is to find the empirical formula. So in each step, we're going to convert to moles. So 1 mole over 12.01 grams for carbon, 1 mole over 1.01 grams for hydrogen, 1 mole over 14.01 grams for nitrogen, and 1 mole over 16 grams for oxygen. When we do that, we get 1.000 moles here, we get 2.000 moles here, we get 8.00 moles here, and we get 4.000 moles here. Divide each by the smallest one. So in this case, we get 1, 2, 8, and 4, since our smallest number was 1. So our empirical formula is C4H8N2O. Now we're going to need to figure out what to multiply that by. So we need to figure out the mass of this compound. 4 C's, 8 H's, 2 N's, and an O. So in this case, because it all worked out that way, we have 48, 8.08, 8 times 1.01, 14.01 times 2, 16 times 1, add those all together and you get 100.14 grams. So to find our multiple, we need the molar mass of the molecular formula, 200 grams, divided by the mass of the empirical formula, 100.14. We get a multiple of 2. So now we take this empirical formula, C4H8N2O, and multiply it by 2. So our molecular formula, C8H16N4O2. So it's an empirical formula problem until this last step where we find the multiple to make it a molecular formula. One last example. We have carbon, hydrogen, and nitrogen, and we have a molar mass of 300. So Carbon 60.0%, hydrogen 12.1%, and nitrogen 28%. So we divide each by their molar mass to get moles. We do that for this one, we get 5.00, 12.1, 1 mole over 1.01, which gives us 12.0 moles, and 28.0 is 1 mole over 14.01, we get 2.00. Divide each by the smallest one, so 5 divided by 2, which is 2.5. 12 divided by 2, which is 6. And 2 divided by 2, which is 1. So we get a 1 to 2.5 to 6 ratio. We can't use a half in our ratio, so we need to multiply everything by 2. 5, 12, and 2 to get the actual empirical formula, C5H12N2. Now we need to figure out the mass of that. So 5 C's, 12 H's, 2 N's, which 5 C's, 60.05 grams, 12 H's, 12.12 grams, 2 nitrogens, 28.02 grams. Add those all together, you get 100.19 grams. So N is going to be 300 divided by 100.19, which will come out to 3. So our molecular formula will be C5H12N2 times 3, which is C15 CH36N6. So those are two examples of molecular formula.